So now that you know that the constants in the system of linear equations are not important in order to determine if the system is singular or non-singular, you're about to jump into one of the most important and fundamental objects of linear algebra, the matrix. Matrices have lots of very important properties, and they arise from many different places in math. In this case, they will arise from the coefficients in a system of equations in a very natural way. Let us go back to the two systems of equations you previously saw. Recall that systems 2 and 3 collapse into one system when you turn the constants into 0. Now, since the constants are 0, you can forget about them. If you take the coefficients of a and b and now put them in a 2 by 2 shaped box, which is called an array or a matrix, that's the matrix corresponding to the system. So the matrix corresponding to the first system is the one with entries 1, 1, 1, and 2. Why these numbers? Because the first equation, a plus b, can be considered the equation 1 times a plus 1 times b, thus the 1 and the 1. And the equation a plus 2b can be considered the equation 1 times a plus 2 times b, thus the 1 and the 2. So in this matrix, each row corresponds to each equation and each column to the coefficient of each one of the variables. In this case, a for the left column and b for the second column. Similarly, the matrix corresponding to the second system is this one with entries 1, 1, 2, and 2. So a matrix is simply an array of numbers inside a rectangle. These ones are simple as they're in a 2 by 2 rectangle, but later in the course, you're going to see larger matrices. And matrices, just like systems of linear equations, can also be singular or non-singular. Since the first system is non-singular, because it has a unique solution, then we say that its corresponding matrix is non-singular. And since the second system is singular, as it has infinitely many solutions, we say that its corresponding matrix is singular. Of course, there are quicker ways to tell if a matrix is singular or non-singular without having to find the solutions to its corresponding systems of equations, as you will see in the next video.